Hi everybody, welcome to our recorded lesson for Monday for maths. This week we're focusing on 2D and 3D shapes, but for today we're going to be looking at 2D shapes. After you've listened and watched this recording, there's a task for you to do which is very closely linked to this on Firefly. It's just a case of naming the 2D shapes that you can see on the sheet. Don't worry too much about spelling, and don't forget to play this recording back at any point, because then you'll be able to see and hear again about these different 2D shapes. Okay, let's have a look. So when people talk about properties of 2D shapes, they talk about these three aspects: sides, angles, and symmetry. So questions about sides could be anything like how many pairs of parallel lines are there. So you can see in this square, just in this shot here, that there are two pairs of parallel sides. There's one pair going across, one, and then another going up. Remember, parallel lines are lines that never meet. So we might talk about the length as well of the sides. These are all the same length. And so are these. These are all the same length too, in the equilateral triangle and the square. Obviously as well with sides, we talk about how many sides there are. That helps us work out what type of shape it is to begin with. So for sides, we talk about length, how many, and whether there are pairs of sides. When we're looking at angles, where we talk about the size of the angles, are they acute, less than 90 degrees? Are they obtuse angles? And are there any right angles? So each shape has angles inside of them, but you just have to work out whether they're all the same or some are different. And so the types we've talked about, some angles have pairs of angles that are the same. Sorry, some shapes have pairs of angles that are the same. So look out for those as well. It helps us identify different shapes. This is what all of these properties do. They help us identify different 2D shapes. We can also talk about the symmetry of a shape. How many lines do different shapes have? This is something that might be newer, but it's something important for year 5 and 6. So as you can see here, if we're talking about the symmetry of a shape, these dotted lines show us the lines of symmetry in this equilateral triangle. So there are 3 lines of symmetry. If you can just see these lines, I'll go over them with my pen. So if we put a mirror line down here, down the middle, if you looked inside the mirror and then looked at the shape, it would be exactly the same on each side. Again here, both sides of the shape are the same line, exactly the same length and size and everything across that mirror line. And again, if you put another mirror across there, the sides are the same. So they're the lines of symmetry in an equilateral triangle. Not all triangles, but an equilateral and equal, where everything's equal. The square has 4 lines of symmetry. 1 there, 2, 3, and 4. I should be using a ruler, but you get the idea. So they're the lines of symmetry. So we can look out for all of these properties on the next few slides. Okay, so let's look at triangles now. There are 4 main types of triangles, and they are all slightly different, and we'll have a look at why. So if we start at the top left-hand side, this type of triangle is called an equilateral triangle. I've written the word equal there at the side to help you. Equilateral means all the sides are the same length, all the angles are exactly the same size, everything's the same. It's like the shape we just looked at. It's got lines of symmetry on it as well. It's equilateral, so that means everything's the same. At the top right here, this is an isosceles triangle. An isosceles triangles, these are where 2 things are the same. So on here you can see the 2 sides are the same length, this one and this one. 2 sides are the same length and one is slightly shorter. And 2 angles are the same length, this one and this one, with this one is slightly smaller. So isosceles means 2 things are the same, 2 sides are the same length, and 2 of the angles are the same as well. We come down here to the bottom right, and the way we can remember scalene triangle is if you just have a look here at this little cartoon fish picture. Fish have scales on the outside of their bodies, and if you could look beneath the scales, you would see these bones beneath the scales. They're all different size lengths and different angles. okay? So if you think of scalene, fish scales below the scales, below the scales of the fish, you find different length bones and different angle of bones like these ones. So scalene means everything is different. And you can see here, no three sides are the same length and no angle is the same. Now the fourth type we want to look at are these right angle triangles. Now a right angle triangle is is any type of triangle really that has a right angle in it. So here's the right angle down here. I'll just draw it in, and it's there for you to see. But these triangles can also be scalene. So you can have a right angle in a scalene triangle. You can also have a right angle in an isosceles triangle. You can't have one obviously in an equilateral because everything has to be the same, and you couldn't do 3 lots of 90. Okay, so a right angle triangle is another way to describe one of these two triangles. So it's sort of a fourth type. So you can see here, these are all quadrilaterals. Quadrilaterals are the name of a group of shapes, clearly all with 4 sides. I put a little picture of a quad in the corner so that you can remember that a quad means 4, it's got 4 wheels. Quadrilaterals are shapes all with 4 sides. Now you're all very familiar with a square and a rectangle, so I'm not going to talk too much about those. But I will put a copy of this PowerPoint with the recorded lesson on Firefly, so you can have a look back at all of this information because it's quite hard to read it all in one go and there's no need. Another type of quadrilateral here is a kite. It's still got 4 sides, 4 angles. Looks like a kite, a traditional kite. And you can see some of the things are the same. So there's 2 pairs. Remember we talked about pairs at the beginning of equal sides. So there's a pair, 1, 2, and here's a pair, 1, 2. So they're equal to each other and so are they, okay? And we have some symmetry down the middle. So if you put a mirror down the middle, both sides are looking exactly the same. And yeah, there the angles look. So 2 of the angles are the same and then 2 are totally different. So that's a kite. I'll look down here at a rhombus. We've talked a bit about a rhombus in our 5-a-day work. It's a pushed over square. It means all 4 sides are the same length, but there's no right angles like a square, look. And that's the difference between a square and a rhombus, okay? So that's a rhombus, 4 equal sides and the opposite sides, the opposite angles are equal and opposite sides are parallel, look. So you see this line, I'll just draw it on, and this line are parallel to each other, so that's a pair. They'll never meet, as well as this line and this line. They're a pair of parallel lines. I could carry on drawing those forever and ever, that way and this way, and this one and this one, and they would never meet if I was using a ruler. Okay, so they're parallel lines on a rhombus, so it's a pushed over square. Now we'll have a look here at this parallelogram next. So you can see the parallelogram in the top corner. Again, this is a pushed over rectangle. Look, there's the rectangle and there's the parallelogram. So it's very similar to a rhombus, but it's not got all sides of the same length this time. It's because it's a pushed over rectangle. Similar properties though, no right angles. And then we come down to the last one, the trapezium, which is a shape you might not have come across that much before. We've got 2 examples of a trapezium here. They always have a pair of parallel sides. So that's the pair of parallel sides. These are not parallel. Look at that one and that one. They're going to meet at some point. They will join up. But they've got 1 pair of parallel lines and they've got 4 sides. This one has 2 sides that are the same length. So although these 2 are not parallel, they've got sides the same length. This trapezium just has 1 pair of parallel lines. It actually also has 2 right angles, but nothing else is the same. There's no symmetry in that one at all. Whereas this one, if you put a mirror along there in the middle, it would look the same on both sides. Let's have a look at a bit more trapezium in a second. Here are 3 more examples of a trapezium. These look slightly different to the last ones, but they're all different types of trapezium, and it basically means, again, I'll go through it again, they've all got 1 pair of parallel lines. Look, they're parallel, aren't they? Even though that one's much longer than that one, they're still parallel. They're still going in the same direction at the same angle. This one as well, different lengths, but that length side and that side is exactly parallel, going in the same way. There's no symmetry here or here. You couldn't put a mirror anywhere and reflect exactly the right shape back. As this one here, the parallel lines go up and down this time. They're different lengths, but they're parallel to each other. No symmetry on that one either. So that's a trapezium. Americans call it trapezoid. Let's not get confused, we call it a trapezium. So here are 3 more examples of other shapes. Shapes that also can be called polygon. I'm going to write that there. Polygons. And polygons just mean poly means more than one, and gon means is a different word for a shape. Polygon, and it just means shapes with more than one side. So a square can be a polygon, but so can an octagon. So any shape that we're looking at, but the general name is a polygon. That's the proper maths word. Anyway, here's an example of a polygon. It's a 5-sided shape called a pentagon. The way to remember it is hopefully with this picture to help you. It's a hand holding a pen, and a hand has got 5 fingers. So you remember it, a hand holds a pen with 5 fingers, pentagon. And the sides, there's 5 sides, there's 5 angles, and in this example, they're all the same length and the angles are the same size. But in a minute, I'm going to show you a different type of pentagon. And there's also 5 lines of symmetry in this one. 1, 2, 3, 4, 5. You can just about see it on with the red lines. This is a hexagon, so this is a 6-sided shape. I don't know if this will help, but I remember it by hexagon. Hex, the German word for a witch, is eine Hexe, and associated with witches and sort of evil things, there's the number 6, 666, Hexe. Hexagon, can you think of Halloween? Hex, a witch, and the number 6. This is a regular hexagon where all the lines are the same length and all the angles are the same size. So it's a regular hexagon. And here we have an octagon, the same thing, 8 sides, 8 angles, 8 lines of symmetry. You remember it, octagon. Octopus has 8 legs, octagon, 8-sided shape. Okay, and now I'm going to show you the difference between a regular polygon and an irregular polygon. So here we have this shape, which I hope you're going to tell me the name of right now. Yep, it's a pentagon. It's got 5 sides. You hold a pen with 5 fingers. Pentagon. This also is a pentagon. Let's just check. 1, 2, 3, 4, 5. But it looks nothing like this one. Why does it look so different? Well, these have all got the same length sides. These haven't. Look, that's a tiny one. That's a longer one. This is an even longer one. And the angles, look, there's a couple of right angles here. So this is irregular. So there's the word irregular. An irregular pentagon is just any shape that you can make with 5 sides that are straight lines that have got 5 sides that join up. And it's actually much easier to draw an irregular pentagon than it is to draw a regular one. So that's an irregular and a regular pentagon. And here we have regular and irregular octagons. This one is obviously regular because everything's the same size angles and the same length sides. Here, this is irregular because all the angles are still the same. They're still the same size, but 2 of the sides are longer. They're a different length. This one here is also irregular. All the sides are the same length this time, but the angles are all different on each corner, on each part. So that's also irregular. And then this one here is there's different sizes of angles and different lengths of sides. So there's a really long side and there's a shorter one. So regular, irregular, irregular, irregular. Okay, it's time to have a go at the naming the shape activity. I'll send the answers to you on Tuesday.